Good morning, everybody, again, for whoever just joined. My name is Efthymios, and today I will be presenting you what's Flutter under the hood and what makes Flutter tick. Basically, we're going to have a inch-deep, mile-wide approach of what's Flutter, so you will get a taste of basically almost every single aspect of Flutter, except from coding, but I will have some code to present. Who in here is a Flutter developer, except from the ones I know? Oh, more, okay. You might find it a bit boring, because it's an introductory talk, but you might also learn something. And so all the other people are Android developers, show hands. All right, maybe I can convince you. All right, so let's start. About me. So I'm Efthymios, and I come from Greece. I'm a CTO at OneRoof. We are a New York-based startup building communities in buildings. And I am the founder of Flutter Greek community. So we do like meetups and things like that, and also a GDE for Dart and Flutter. Here is the agenda. It's a big agenda. Let's try to see how much of it we can cover. First of all, we will see what is Flutter, and basically try to get you to understand, what's this, what are the benefits of using it, and all that. Then we're going to touch a bit the architecture. We're not going to get into very deep into architecture, but we're going to see how it is architected, the framework itself. And then everything is a widget is a catchphrase from Flutter developers, because basically everything you do comes from a single widget, which has built then a widget tree, which we'll see how Flutter manages those trees with tree management, and how many it creates and how it manages them. And then state management is how Flutter manages the change of state in terms of how it gets repainted and rebuilt the UI. At the end, if we have time, we'll have a very, very short demo, like to show you how you can create your first ever Flutter app out of the box, 2 commands, and maybe we can go through the code. Now, in terms of questions, I have a Q&A at the end, but if you feel that you have a question that prevents you from following on the talk, please raise your hand, and maybe we can solve it. It's not to start a conversation, it's if you have a question that will, if you don't understand that, then you cannot follow. So, what is Flutter? Flutter is an open source. This comes out of Flutter website. So Flutter is an open source framework by Google for building beautiful, natively compiled, multi-platform application from a single code base. So basically, there are a lot here. So it says natively compiled, which means that, and maybe I can skip to that. So in the advantages that I see in Flutter, and the things that convinced me to try it out and then haven't looked back, is that it compiles to native ARM binary. And then it takes over the screen and paints everything itself, which means that it does not rely on any OS-specific code to draw itself, to draw its components. It just draws and paints everything itself. The good thing about that is that you can customize it however you like. You can have a uniform way of presenting your app throughout the platform. Let's say you want to have the same look and feel. You don't want to rely on native components or the native look and feel of every app, of every platform. So, and that's another powerful thing. Also, the way that you build a Flutter app is that you declare the widgets that you want to be in the screen, and then Flutter takes this declarative widget tree that you have built and paints itself. We'll see how that is done. Also, it uses Dart, which I'm kind of being a fan of lately. Who has used Dart? No Dart? Okay, all right, cool. Also hot reload, but that hot reload is not exactly what actually drove me. The hot reload is that whenever you do a change and you save the file, because of the way that the Dart was built, it has an ahead of time and a just-in-time compiler. So when you develop the just-in-time compiler, it kicks in, which means that whenever you change something, it automatically picks up the change and show you the result in the emulator or on your device without the need of rebuild or restart or anything like that. And also, it has the ability to talk to native code in a very elegant way, in my opinion, using native plugins. So basically, the majority of the apps that we are building is that we get some information from the server and we show it in the screen, and maybe we get some user input and we change something in the server. Basically, that's maybe 67%, maybe even more, maybe 8% of the apps that we are building. So basically, you could have that in Dart, and you can get like 2 platforms for free out of that, because like you don't need any native code to run something like that. Of course, then you have other things that you might rely on, like let's say you have some push notifications coming in and some deep linking that you want to do, and this or something in the sensors of the phone that you need to pick up. All of those need to be done in the native app, which means that with Flutter you create a native plugin for that, and let's see how it works. So wherever you see the orange boxes are where the API boundaries are. So you have Dart code, right? The custom Dart code, and it needs to pick something from a sensor, right? So it sends an actual message. It opens a message channel to the native app, to the native code, and sends a message and saying, hey, sensor library, or whatever native code you have there, can you give me the GPS position, let's say, right? So then the native code runs and message back through the message channel to the app the information that it requested. And that's very powerful, because even though, like in Flutter, we might not have certain plugins, but if you have the libraries for iOS or for Android, you can create a wrapper, a plugin wrapper around them, and use them as Flutter native. Now, let's see the architecture. There was this talk given by Ian Hickson. Ian Hickson, one of the creators of Flutter, and it's called the Mahogany Staircase, and it presents the Flutter layered architecture. It's about an hour. It's 2016, but it holds up really, really well, because the underlying architecture has not changed that much. So you can go there, you can scan the QR code, go to the YouTube talk, and check it out if you want something in depth. We're going to talk about it here. So this is a lot. What we want to present to you basically is the framework part. So you see there is a framework part, it's all in Dart, and then there is the engine and the embedder. So the engine, if you see there are the, where is it? No, sorry. So in the engine, yeah, you have the platform channels, you have like all the low-level things that they needs to be built in order for the Dart code to be run. And the embedder is for different, it's something fairly new, like I think a year or a couple of years now, that it takes the actual framework and embeds it in the devices, because now Flutter runs on not only on mobile devices, also runs on web. It also runs on other embedded devices, like it also runs on desktop. And it's quite ambitious what the Flutter teams wants to do with that. But let's go to the framework. We have the foundation layer on the low level. The foundation are all the utility classes and things that help out the upper layers, right? Above that, we have the animation, painting, and gestures. So this is how Flutter paints itself, right? And all the code that it needed to be painted itself is over there. And it's fairly down the bottom because all the other layers need, so the way that the dependency goes is downwards. So material needs widgets, which needs rendering, and animation, and maybe the foundation classes. So the dependency goes down. So that's how it's stacked up as the architecture. So we have the rendering library, let's say component layer. We have the widget layer, which is kind of agnostic of how it's going to be presented itself. It's just gonna, okay, if it's a text widget, we know it's a text, but on top of that, we have material and Cupertino. So the Flutter team actually build on top of widgets the whole material UI experience and some of the Cupertino components. So if you want to have like something more natively, you can use one of the two libraries, but you can also customize it as you like. Everything is a widget. So as I told you in the beginning, that's a catchphrase that we have in Flutter, because everything starts from a widget and all the way down, it's always widgets. And that's a declarative way of structuring your app. It's kind of like building the whole UI as you're building a widget tree. Let's say you have an XML or HTML, right? And HTML is a tree, right? Because they are all nested inside. Everything is nested inside something else. You cannot exist like by its own. It has the HTML tag, then you have to have the body tag, and then you have to have like, I don't know, whatever, and a UL and a LI, and you know, all that needs to be structured that way. That's how Flutter works, but it's not declared in a way that you will write XML in order to create. You have to write code, but the code is, the widgets are inside each other. There are three types of widgets. It's stateless widgets, stateful widgets, and inherited widgets. We're going to go through them now just to touch and see what they mean programmatically. Okay, it's showing. So this is an example of a stateless widget. Does nothing more than what it says. It keeps no states. Whatever it takes, like it should be presented, it's also good and simple. That's a stateful widget. If you look closely, the stateful widget has a create state method. The create state method is very important when we're going to see the state management later on. So the stateful widget has a create state, and inside your state, you build your widget, your next widgets, and also keep anything that needs to be changed there. We'll have an example later on. It will be showcased better. And here we have the inherited widget. So what's an inherited widget? An inherited widget is a special kind of widget that can propagate itself down the widget tree. This was created because of state drilling. Do you know what state drilling is? Okay, so state drilling is that if you have a state and it's like in your widget tree is very, or in whatever tree is very up in the root of the tree, near the root of the tree, and you want to access it in, let's say, the leaf of the tree, then you have to pass that state down to all widgets so the last widget can get it. In order to avoid that, here comes inherited widget. And inherited widget actually says, okay, I am here, I have a state you might want to get. So in order to get it, I don't have to pass the state through all the widget tree. You just get me, and I know how to fetch myself. And then if you get me in whichever leaf or in whichever part of the graph of the tree you are, then you can have access to the state without having a state drilling. Updates should notify. That's a method that tells so whoever gets a reference of that inherited widget, let's say that the color in this inherited widget changes. And update should notify actually communicates to to whoever widget it has a reference into that inherited one, if they need to update their state because something got updated there. So that's what it does. So let's say that you do get a reference of this state widget, you do get the color out of it, but then the color changes because of some other action, then all the other widgets that have a reference to that needs to change, needs to update their color as well. The off building context, the off and gets a build context is the way that you are getting this inherited widget down the widget tree. So it's a static method. The build context is something that gets passed to all build methods to all types of widgets. So all widgets that build something have access to the build context. The build context actually holds references to whatever is above the current widget in the widget tree. So if this inherited widget is above the widget that you are building, you can get a hold of it by using this depend on inherited widget of exact type. It's kind of like a mouthful, but it actually tells the context, hey, I want to get a reference of this type of inherited widget wherever it is above me. And it will return it, and you have then a reference. Tree management. So there are three types of trees inside the Flutter. Well, actually, one is outside. So the widget tree is the configuration, let's say. The widget tree is what we build. We create a widget tree, and then we pass it to Flutter. Flutter then creates two more trees, the element tree and the render tree. Those two trees are like the element tree keeps track of the life cycle. So what has changed, what needs to be changed, and it keeps track of the widget tree to see if something has updated. And if something has been updated, then it needs to tell the render tree to update itself. So render tree paints the actual thing. All the other things are for management. Well, the first one, the first one is for development. The second one is for like the lifecycle management. But let's drill a bit into them. So this is an example of a widget. Like it's a simple container, has a color of blue, and inside it has a row with an image and a text of, say, A. So a very, very simple thing, right? And this is what the widget tree is going to be represented inside Flutter. So you give that to Flutter, and Flutter understands this widget tree. So it has a container. All the things that are in a dotted line are kind of implementation details. So I will not get into depth into them, but let's focus on the ones that are in blue. Those are the widgets that we told Flutter to create. So we have a container, we have a row, we have an image, and we have a text, and all of them are inside one single tree, right? Now, Flutter takes this widget tree and creates what's called an element tree. An element tree is different types of objects. It's not widgets anymore. They are called elements. And the elements, again, will have information of and references to the widgets. So the container with the component element will have a reference to the container, right? So everything is going to have a reference back to a widget. And that's because if something changes in the widget tree, the element tree needs to know about it and needs to update itself in order to maybe trigger a repaint, or maybe no. That's that's a decision made later on. The render object element is an element that actually, as it says, renders something to the screen, right? So here we have a couple of them that they actually do render something to the screen. And how they do that? So this is the create element. Sorry, this is the create element. Oh, yeah, sorry.
In the previous slide.
Yeah.
The widget tree, which of those circles in the element tree represent this?
Okay, so it's not one-to-one. So the render object element might be represented by the either the container or the color box. So it's not exactly one-to-one. I have an example that's one-to-one, that I think you're going to understand later on, all right? So the create element method actually creates the elements from the widget. Every widget has a create element, so every widget will create an element. And you can create a stateless element, or you can create a stateful element. But coming back to your question, we see stateless element and stateful elements, but we don't see all the other elements we said, like component element, a render object element. That's because the stateless element is inherits from those elements. So it's not like a simple one-to-one. It has some inheritance built into it. So it's not like exactly one-to-one to say, okay, this is a stateless element, so it must be there. It's not actually a stateless element. It might go all the way to a component element. And this is the render tree. So whatever we have, so you see the green, the heavy green elements there. Those are the ones that are creating the render tree, that are creating the render objects. And the render tree is what actually does the action of rendering, of painting something in the screen, right? And you might wonder, why? Why would we need like 3 trees in order to paint something in the screen? Will become apparent when we talk about how Flutter changes the state and how it repaints whenever its state changes, and how it does it performantly, just because it only needs to repaint certain parts of information that comes from the element tree. So this is another catchphrase we say: constraints go down, sizes go up. So in the render tree, right, you have to paint something, but you need to know the size, right? So the parent will always say, hey, to the children, hey, children, those are your constraints. You have to have like maximum this length, with this width, maximum this height, minimum, like all the constraints are passed down. And then the children themselves decide, okay, oh, that's the constraints that I have, so my size is that one. So they get the constraints into the calculation of their size. And then their size goes up, and then the actual render object knows how to render and know how much space this needs to be in whenever they paint. And here is how we create a render object. From the render object widget, we create a render object, and the implementation are left out because it's very, very much implementation specific, and we really don't have the time for that. State management. I hope now I'm going to answer your question. So we have this app. Like, this is the basic app you get with whenever you have a Flutter create. We have time, we'll watch that. And it's a very simple app. You have a My Home page, right? And it has a title, and it has a state. And inside the state, you have a build method, and the build method is on your right. So just split it up so you can follow it. It will take like more screen. So it creates a scaffold, an app bar, and in the body of the scaffold has it centers it in the column, and it has 2 children, a text, and a text with the state of the counter. And also we have a method to increment the counter. Basically, that's the app. You hit this button, and it just counts the number of tabs that you put, right? So everybody has this. It's very important, okay? From this app, this is what the widget tree looks like. We have a My Home page. We have a scaffold, and inside the scaffold has an app bar, and the app bar has a text, and it has a floating action button. That's what the FAB stands for. And this has an icon. And also you have in the body, you have a center column with 2 texts, right? Now, everything in the dotted line, we don't really care for our example. So we only care the ones that are in solid lines. So we have the My Home page, we have the floating action button, and we have the text. Actually, we don't even care about the floating action button because it's just something that triggers. We can ignore the floating action button just for simplicity's sake. So this will become this. We only care about my home page, which is a stateful widget, and its state, which has in the text that actually shows the state, right? So my home page has a stateful element, and the stateful element creates a state, okay? And that's my home page state that you show in the example. This is not part of the tree, the state. The state is part of the stateful element. The state is there so that it will tell the stateful element, if something has changed, you have dirty state, you need to rebuild. That's the whole thing. That's state, that's what it does. It triggers a rebuild in the stateful element. And we have the text, which is also a stateless element. Now, remember what we did? We tapped on the button and the counter went up, and then the update, the counter update repainted, right? So let's see how Flutter does that. So the counter was 0, now the counter is 1. So floating action button pressed once, and now the counter is 1. Now, this state says to the stateful element, hey, I think you have dirty state because my state got updated. So you have to check to see what you need to do in order to rebuild. What it does is, okay, because I am, because I have a new state, then I tell the home page, hey, okay, so you have a new state. So the home page, because the widget tree is immutable, meaning that you cannot update anything in the widget, you replace everything. So my home page creates a new text. Well, actually, Flutter creates a new text widget and says, okay, this has the new state. Let's see what's with the old state. The old state is this text underneath my home page. So what Flutter does is it removes these and all its dependencies. So the text widget with the previous state got removed. And now, without changing anything else, so my home page remains the same, stateful element remains exactly the same, stateless element remains exactly the same. So the element tree didn't change at all. The element tree remained the same. The element tree just switched references. That's because the new widget that came was of the same type as the old one. So the text with the 1 came, and the old one was text as well. So the stateless element says, oh, okay, I have the same type. So basically, I don't need to rebuild myself. I'm just going to switch my references to the new one. And then I'm going to update myself. And that's what it does. So it takes the new widget, and then it updates itself, which then gets propagated to the render tree in order to get repainted. And then the render tree also does not switch, it does not replace the render objects, but actually it updates them. Says, okay, you have new state you need to paint. Oh, okay. So let's see what we need to paint there. We only paints like only the one small thing that's there, right? The number 1. Okay, let's create. Let's see how Flutter creates. You can create a new Flutter app. Everything okay? I know it's kind of hard to grasp because it's kind of complex how it does it, but I try to drill it down. So we say Flutter create, and Flutter create has a bunch of options. If you want to take a look at them, you can just do a -- help. What we want to do is we want to create a type app, and we want to call it a counter. Okay, so Flutter created it. Now we can get into the counter app and open it up to see what we have. Can you see it? You need a bit bigger. Can you see? All right. So let's take a look of what the project looks like. A project has an Android project inside it. It also has an iOS project inside it. And here in the lib is where the Dart code and Flutter code lives. We only have one file. And in the main, so in Dart, in order to run something, you have to have a main, in other languages as well. And we have the run up. Run up is a function that bootstraps the whole thing. So run up takes a widget, and it bootstraps the whole framework and the widget tree and everything. So right now we have a my app, which is stateless, right? And it has a material app. A material app is a kind of a helper widget for material-based projects. So you can get a theme there. And also you have a home, and you can have fancy navigation, but it's not time for that. And we see that the material app has only one app, which is my home page. This is the exact same code that we've seen, only with more comments. So we have the title, right? And we have the increment counter and everything. So if we want to run that, might take some time. Until then, I'm going to show you. So this is the Android project, right? You can come in here, right? Drill all the way in the main activity. And here is where you can write some bit of code natively. And here is where you can open up a message channel with the Dart application, so you can send messages, and then you can write native code there that will communicate with the Dart code. But, okay, so the app has run. It's here, so you can see it's the same functionality. And let me demonstrate one last thing, which is hot reload. And let's say we go to the text all the way here. And let's say, okay, we didn't push it, tapped. So the minute I save it, take a look at the text there. It changed to tapped, but it kept its state. So 10 didn't become 0. 10 remained 10. Why is that? Because the just-in-time compiler figured out that you only change one last thing in the widget tree, and the element tree remained the same, the state remained the same, it kept its state, and the only change that was done was in the painting of the stateless text. Okay, and I think, all right, so we have some time for questions. That was the demo. Questions. We ran through, I know I ran through a lot, and like each and everything that I presented would be a talk of its own. But I just wanted you to have a wide overview of what Flutter can do. Any questions? Oh, okay. Yes? How? Yes. Yes. So it works in real projects, exactly as I showed you. The only way that it does not work like that is, let's say, when you have you had a stateless widget somewhere and now it's stateful. So the widget tree needs to change and everything needs to change. Then you have to have something that's called hot restart. You don't have to rebuild, but you restart the application. Hot restart kind of restarts the whole application, but doesn't build it again. Yeah. Right, good question, thank you. So, limitations for Flutter. I would recommend, if you have a simple app that takes data from a server and presents it to a screen, you can have that in Flutter with no limitations. And if you update like data in your own servers, like you don't have any native dependencies, or your native dependencies can be covered by the ecosystem, because we have, in Flutter, we have a lot of plugins and a lot of plugin ecosystems. So basically, you can find anything in terms of a native device libraries that you can use. Now, if your app is very niche and does very, very specific thing, basically it's a map app, right? And it's like totally 100% a map app, right? Then I would recommend, okay, check it out. Maybe it doesn't worth it, because maybe the majority of your code is going to be native. But for other cases, I don't see why you would be limited by Flutter. Other questions? Yes. Performance comparisons, yes. So because it compiles into binary, into ARM binary, actually you can run a Flutter app in an M1 chip because it's ARM. The performance, and because of all the optimization that I showed you with the trees and how it repaints and gets repainted, Flutter can keep a 60 frames per second animations. So it is performant. I don't see any. There are some problems with shading in iOS. I think they are addressing those in the initial. So if you have an iOS app and you have very specific conditions, you might see a junk in your first animation, your first scroll, let's say. But after that, because it gets cached, you don't see any other things. So in terms of performance, it is performant. I don't see, like, I don't know where do I compare it to, like native? So the comparison is native and Flutter. I don't see the difference in performance. What I do see is the difference in development lifecycle because of hot reload and hot restart. It's much more faster to go. Actually, there's a lot of Flutter developers that are sitting down with the designer and they are like kind of having a session where the designer just tell them, okay, change this color, change the other, just change it, and it's there, like in code. You don't have to have a different design. And had another question somewhere? Dependency injection. Good question. So you could achieve dependency injection either through, like if you want to go low level with inherited widget, but there are libraries out there that can help you out. One of my preferred libraries is Getit, and Getit is kind of like a quote-unquote simple registry where you can register all the dependencies, and whenever you need someone, you get it from the registry. So if you need like an instance of something that has some dependencies, because you have registered all the dependencies there, you get it from this registry and it's already there. But in your code, the dependencies are coming into the constructor. Had another question somewhere? Yeah? Oh, I can't hear you. Maybe you can speak. Oh, I can't hear you at all. Sorry. I cannot hear you. Sorry. I have a hearing problem, so I cannot hear you. Yeah, maybe if you could. Any? Oh, bottlenecks. Okay, in the message channel. Got it. Okay, so the question is if there are any bottlenecks in the message channel. What kind of bottlenecks? I mean, okay, I'm not asking you because I cannot hear the answer. I don't see how it could be because it's just a queue, actually. If you look at it, it's just a queue. And the messages come in binary form. So you get binary, you serialize binary, and then that's how you communicate. And binary comes back and forth. So I guess that whatever bottleneck limitation might be there for a queue or a message queue might be there for message channel as well. But having said that, you can have multiple message channels open. Doesn't have to be like one plugin, one message channel. You can have 2 or 3 message channels if you want to. So if you see that something gets a lot of traction inside you, you can split it in another message channel. Answer? All right. Yes? Yeah. So about memory, there is a misconception that stateful widgets will increase your memory, but there is a trade-off. So yes, stateful widgets will sit on the widget tree for long periods of time. That's why you don't want to have a lot of them, but that doesn't mean that you don't have to have like any of them, right? Because how else will your app react? So in terms of RAM, of memory, it just depends on the way that your app looks like, right? If your app is heavy on images, is heavy on SVGs, or it's heavy on animations, you might have a RAM, like you might have more in terms of Flutter. But you could have that. And it's always a trade-off. Like if you want more speed, you have to have a trade-off with RAM. If you want like less RAM, then it's a speed thing. Did I answer your question? All right. Any other questions? Oh, and we reached the hard deadline. All right. So that's it. Thank you, everybody. Thank you very much for being here.